The US military operates 11 aircraft carriers, far more than any other country on Earth. These vast floating airfields are what allow America to project power far and wide across the world, thousands of miles from its own soil and shores. They provide unparalleled operational flexibility, capable of carrying out combat, surveillance, deterrence, and security missions almost anywhere. And they just got an extraordinary upgrade. A science fiction-style futuristic weapon, the Locust laser, designed to counteract arguably the biggest threat of the 21st century battlefield: drones. This new weapon can quite literally burn unmanned aerial vehicles, UAVs, right out of the sky, melting their structural components and damaging critical systems, all in the blink of an eye. And this is an invaluable addition to US aircraft carriers, because the drone threat is rising with every passing day, and for too long the US Navy hasn't had an intelligent and cost-effective way to counter it. Back in October 2023, for example, a billion-dollar American warship suddenly detected dozens of threats on its radar screen while traveling through the waters of the Red Sea. Those threats weren't just cruise missiles or enemy jets. They were drones and cruise missiles operated by Houthi rebels in Yemen. Cheap, mass-produced UAVs, barely worth $50,000 each, but packing enough explosives to deal serious damage to almost any target in their path. And on that particular day, several commercial vessels, as well as the American warship, were in their firing lines. The Navy crew had to react fast, and with no other options at their disposal, they were forced to rely on the ship's traditional defensive systems, interceptor missiles. These missiles weren't designed with drones in mind. They were just made to take out enemy fighters, bombers, or other missiles, hugely important and expensive assets, often worth in the millions or even tens of millions of dollars. Interceptors too are often valued at least $1 million, sometimes significantly more. When you're targeting a fighter with interceptor missiles, cost effectiveness isn't much of an issue. It's perfectly rational to throw a few $1 million worth of munitions into the air if it means bringing down an enemy jet that's worth significantly more. But when you're using $1 million missiles to eliminate $50,000 drones, that's a very different equation. Imagine a warship or aircraft carrier having to contend with whole drone swarms, each made up of dozens or even hundreds of kamikaze UAVs. It would burn through literally hundreds of millions, if not billions of dollars of missiles in a matter of weeks. That's not sustainable, not even for the US, which has by far the biggest military budget on Earth. Instead, if you want to deal with drones, you have to find more affordable and efficient ways to do so. That's a lesson that Ukraine learned in its war with Russia. The Ukrainian defense forces regularly have to contend with massive Russian drone swarms, but use an array of cost-effective defensive measures to bring them down, including everything from AI-powered turrets and mobile fire groups to interceptor drones and electronic warfare (EW) jammers. And the US defense industry has been keeping close tabs on the situation in Ukraine, learning from Kyiv's defenders, digging into the data to find out what works, what doesn't, and how America's forces can emulate or iterate Ukrainian tactics to level up their own counter-drone capabilities. Because drones aren't going anywhere. This isn't just a phase or temporary tactic that will soon be outdated. Drones are both the present and the future of warfare as we know it, and it's not hard to see why. They're remarkably cheap to make, costing a mere fraction of the value of typical cruise and ballistic missiles or guided bombs, but have astonishing potential to eliminate enemy forces, damage and destroy infrastructure, and cause absolute chaos wherever they're deployed. We've seen that in Ukraine and in the Middle East, and many of the world's leading militaries are already hard at work developing their own next-generation drones with bigger warheads, better motors, smarter AI brains, and unprecedented capacities. China, for instance, has developed astonishing autonomous swarm technology that allows literally dozens of drones to seek, identify, track, and strike targets with almost zero human intervention required. Nobody can afford to ignore the rising importance of UAVs, especially not the US, which has been the world's mightiest military force for generations. To maintain its spot at the top of the rankings, it has to not only develop its own drone army, but also find the best ways to counter and eliminate enemy drones, both in the air, on land, and especially at sea, as the US Navy has to contend with hundreds of incoming drone and missile threats in the Red Sea alone between October 2023 and January 2025. That number is only going to rise as the years go by, with forces like the Houthis easily able to produce vast quantities of Samad or Qasef-style drones in the hopes of overwhelming their opponents and bombarding American warships and carrier strike groups. As explained, relying on missiles to stop the swarms is not a viable solution. Not only do they cost a fortune, but even the biggest warships can only carry so many missiles at a time. Eventually, they'd run out of munitions and become little more than massive sitting ducks. But what if those ships could use a different kind of defense? A weapon that's cheap to use, effective against all forms of UAVs, and never runs out of ammunition. That's where the Locust laser comes into play. And while it might sound like something from a sci-fi movie, it's very real and already being equipped to American aircraft carriers as we speak. Indeed, on April 20, the Warzone, along with other military news outlets, reported that the US Navy had fitted and tested a Locust laser system on board the Nimitz-class aircraft carrier, the USS George H.W. Bush. This is believed to be the first time that the Navy has actively used this type of technology on a carrier. It also appears to be part of a long-term strategic shift within the Navy towards direct energy weapons, with Chief of Naval Operations Admiral Darrell Coddle telling reporters in January of 2026 that he wants to see more American warships equipped with laser systems, and for those same lasers to become the first and primary line of defense against close-range threats. This is my goal, if it's in line of sight of a ship, that the first solution that we're using is directed energy. While news of the Locust on the George H.W. Bush didn't break until April 2026, it's believed that the actual testing was carried out back in early October of 2025. The Navy shared pictures of the system in situ, along with an encouraging caption. During the live-fire event, the Locust LWS laser weapon system effectively detected, tracked, engaged, and neutralized multiple unmanned aerial vehicles, making a milestone toward fielding operational directed energy capabilities. A press release from AeroVironment, the defense firm that developed the Locust, provided further details. The successful demonstration of its palletized Locust laser weapon system, LWS, aboard the USS George H.W. Bush CVN-77 in October 2025 was conducted in collaboration with the US Navy and the US Army Rapid Capabilities and Critical Technologies Office, RCCTO. The statement went on to confirm that the Locust's palletized high-energy laser PHEL system tracked, engaged, and neutralized multiple target drones, marking a major milestone toward fielding operational directed energy capabilities across all domains and platforms. The company added that these successful tests prove that the Locust is a platform-agnostic innovation, able to seamlessly transition from fixed-site and land-based mobile platforms such as the Joint Light Tactical Vehicle (JLTV) and Infantry Squad Vehicle (ISV) to the dynamic and demanding environment of a maneuvering aircraft carrier. That fact is of huge importance, as it means that the Locust could effectively be deployed almost anywhere the US needs, both on land and at sea. It could be fitted to future warships and next-generation carriers as a standard defensive system, as well as ground vehicles, performing to the same high standards in every environment. But before we take a closer look at how this system actually works and what it's capable of, you're watching The Military Show, and if you haven't subscribed yet, now's the time. Now, the central element of the Locust is a laser-directed energy weapon housed inside a turret, which is also equipped with built-in electro-optical and infrared video cameras. Those cameras are responsible for finding, identifying, and tracking targets as they enter the system's range. Various tertiary sensors, including high-frequency radars and passive radio frequency signal detection systems, are also integrated into the Locust, helping to cue and control the laser, which is believed to have an estimated 20 kilowatt power rating. That's actually at the lower end of the laser power spectrum, but don't let that fool you. The Locust laser is still more than strong enough to wipe out smaller drones with ease, and there's reportedly room to crank up its power levels. In fact, the system has already been demonstrated with a slightly stronger 26 kilowatt power rating, and may be able to scale even higher, though it's not quite clear how high it could theoretically go while maintaining its current form factor and design. And the Navy isn't the only branch of the US military that's experimenting with this exciting futuristic technology. Back in December 2025, reports confirmed that the US Army had received delivery of palletized Locust layers, as well as additional systems that had been mounted onto tactical and infantry squad vehicles, JLTVs and ISVs. The Marine Corps has also shown active interest in acquiring JLTV-based Locust systems, but the recent news of a Locust on a carrier is the first time we've officially seen the Navy working with this type of technology. It's an exciting move, but not a surprising one when you consider the numerous benefits that these lasers bring. First, there's the cost advantage. While the Locust system itself isn't cheap, with a single unit costing around $8 million, the laser is astonishingly affordable. AeroVironment revealed that a single blast of energy cost about $5, and that's often all it takes to take out a drone. $5 to wipe out a $50,000 threat. That's incredible, and it's infinitely better than trying to use a $1 million missile to accomplish the same feat. There's also the not insignificant fact that lasers, unlike rifles, conventional air defense systems, bombers, and rocket launchers will never run out of ammunition. They offer unlimited magazine depth, as long as they have sufficient power and cooling to keep them running smoothly. These systems can keep firing for as long as they're needed. No reloading, no resupplying, no need to go back to base and spend hours bringing more munitions on board. That's so important when it comes to the drone threat in particular, because drones are so cheap and easy to make in massive quantities. We've seen the likes of Houthis send out dozens of drones at a time. Russia has gone even further in Ukraine, sometimes dispatching close to 1,000 drones in the span of a single night. You can't counteract those kinds of quantities with traditional munitions. You need a weapon that can fire frequently, cheaply, and without delays or disruptions in between each shot. That's why lasers are so valuable right now. The Locust also has the benefit of flexibility. As touched on earlier, it's already been seen in several formats, like palletized and containerized systems that can be easily moved from place to place, as well as systems that come affixed to vehicles. The Locust seen on the George H.W. Bush was simply rolled onto the deck and lashed down in a matter of minutes, and that means that these systems can easily be set up or removed on demand, depending on the mission requirements. It's worth noting too that this is just one of several directed energy systems being looked at and tested by the Navy and other branches of America's armed forces. Back in 2024, for example, reports revealed that the Navy had tested the high-energy laser and integrated optical dazzler and surveillance Helios system aboard an Arleigh-Burke-class guided missile destroyer, the USS Preble. Around 3 times stronger than Locust, Helios has a 60 kilowatt power rating and can integrate seamlessly with the Navy's existing Aegis combat system. It's capable of both dazzling enemy threats, which basically means blinding their sensors and cameras, and burning them, heating up their critical components through a concentrated beam of energy until they quite simply overheat and fail. In testing, just like Locust, Helios proved highly effective at engaging and neutralizing UAVs. And just like Locust, while the system itself is quite pricey, Helios barely costs anything to actually use. The US is also hard at work on even bigger and stronger laser systems. In June 2025, for example, a project called Songbo was announced, with the goal of creating a 400 kilowatt laser system. That would be around 7 times stronger than Helios and about 20 times stronger than Locust, with the ability to engage and eliminate not just drones, but a vast array of other threats from cruise missiles to small boats. To call this technology game-changing would be an understatement, and its potential is almost limitless. As Admiral Coddle notes, as you increase power, the actual ability to actually engage and keep power on target, and the effectiveness of a laser just goes up. With all that said, lasers aren't without their issues. If they were perfect, they'd already be in widespread use across the US military, rather than still in the testing or experimental phase. One problem, for example, is that a single laser system can only engage one target at a time. That's an issue when you're talking about dealing with vast swarms of drones, potentially made up of dozens or even hundreds of targets, all moving at speed. Even though it only takes a fraction of a second to actually fire a laser, the system still needs time to lock on and track its targets, as well as calculated shots in between each usage. In addition, a downside to laser weapons in general, at least in their current form, is that as the beam gets further away from its source, it becomes weaker, as the beam itself starts to diverge or spread out, which reduces both its density and intensity. The atmosphere also plays a role in this, absorbing or scattering the light as it travels. In combat terms, that means that for lasers to have the best chance of bringing down enemy threats, they either need to have a large amount of power at the source, or they need to fire only when their targets are quite close to them. On top of this, lasers are impacted by the weather and other environmental factors. Smoke, dust and rain can all interfere with the laser's power and accuracy, further reducing its range and restricting its effectiveness. Then there's the fact that these systems also compromise a quite delicate component. Lasers often need sensitive optics to function correctly, for example, and there are doubts about how well those kinds of parts will cope when strapped to the back of warships and forced to spend lengthy periods at sea, exposed to the elements and the salty ocean air. Even with these issues, lasers like the Locust are inevitably going to see wider deployment and more active use in the years ahead, and it'll be up to the world's top military engineers and developers to find ways to counteract or work around their limitations. And with some of the finest minds already on the case, combined with a clear desire at the highest level for more laser integration in the Navy and beyond, it's likely that the US will lead the way in this regard. What's more, this is just one of the many ways in which the Navy is upgrading its warships, destroyers and aircraft carriers to become more drone resistant. Again, taking inspiration from Ukraine, the US has also started testing and fielding interceptor drones. Back in March 2025, for example, the 3 Arleigh destroyers in the USS Gerald R. Ford carrier strike group were seen sporting new launcher systems, not just for missiles but for drones too. The Raytheon Coyote Block II and the Anduril Roadrunner M drones, to be precise. Those are both counter-drone interceptors designed exclusively with one goal in mind: to hunt down and take out enemy drones before they have a chance to strike their targets. And they're both incredibly good at what they do. The Coyote, for example, can reach peak speeds of up to 370 miles per hour. Inside, it carries a 4-pound blast fragmentation warhead with a proximity fuse, and as soon as it gets close enough to an enemy drone, that warhead detonates, blowing up the Coyote itself and whatever enemy drone is unfortunate enough to be in the area. The Roadrunner is arguably even better. A twin-turbojet interceptor drone, it can be launched, track down its target and engage enemy UAVs either with manual control or autonomously, using its own AI brain. It also has the ability to return to base if it doesn't find a target in time. It can land safely back at base, get refueled, then go again for another hunt. At $500,000, it's reasonably pricey for a drone, but still far cheaper than an interceptor missile. And with these unique forms of defenses aboard its aircraft carriers and warships, the US Navy is well and truly entering a new era, one defined not by warhead sizes or missile price tags, but by systems that are more efficient and cost-effective than anything that's come before. Now, you can learn about another exciting US military innovation in this video, which looks at the suspected deployment of a top-secret surveillance drone over Iran. Alternatively, check out this video to see how a more conventional piece of American hardware, the F-22 fighter jet, has proven to be the greatest and most dominant aircraft on Earth. And for more military analysis, insights, and breaking news reports, make sure you're subscribed to The Military Show today.